Good morning all, welcome back to the second day of the Nextflow training workshop as part of the NF Core Hackathon. First thing I'd like you to do is we'll just need to log back into our AWS accounts that we've got set up for the training, so you can find those instructions over on the Secura training website. This is just the first step that we did yesterday. We should already have the environment set up, but the first thing we'll need to do is just to log in via the Cloud9 portal here, using the account ID, your username from above, and the password which is in the chat. So I'll just give you a minute or so to do that. I will put the password in the chat now. Make sure your viewer in the Frankfurt region. My account's in Ireland for today. And once you find your account, to make sure that you're in Frankfurt, you're logged in, you should be able to have the Cloud9 ID to load up here. The nice thing about the Cloud9 environment is that everything is saved from when you were when you had the session open last time. So all of your files will be there, the files that you had open, and even the history of your terminal, I believe. Okay, so today we're going to start on the Nextflow channels. So we can skip down on the left-hand side. You can see where we're up to. I'll just do a quick recap of the script that we looked at yesterday. And then we can, if anyone has any questions on that script, please ask those in the chat. And if there's anything that was not clear about our first script that we have. So this is this one here where we have, we define some parameters, which are inputs to our pipeline. We create a channel, which will contain that input. And then we have these two processes. The first is splitting our letters, which creates two files, two chunk files. And then the second step is we convert the contents of those files and we make them uppercase. So we just cat them. The key thing that we saw at the end of yesterday was that this channel here, letters, creates a single element which contains a tuple of the files, chunk AA and chunk AB. What we do with the flatten operator here is we flatten that tuple into a channel which contains two elements, each of those files. And the fact that we do that, the fact that we change the contents of the channel is what drives the execution, is what makes convert to upper run twice, or run however many elements that we have in that channel. So if there's no more questions on that, we can jump straight into the channels themselves. Okay. So the first data structure that we're really going to look into deeply is the channel, and as I said, the main constructs that we have in Nextflow are channels and processes. And channels are the real data flow programming part of Nextflow. They are what holds our data, and they're what essentially passes each data type or data structure from each process to another, because you see these are very important. You can see this visualization here. Imagine that you had task alpha and task beta, or process A and process B, and you would be sending the files, in this case, from the output of one task to the input of another. And this implicit connection is what defines how the pipeline runs. And we saw yesterday at the end, it's actually the structure of the data inside those channels which drives how the processes are executed. We have two main types of channels. For the majority of use cases, you're using a queue channel, which we'll describe in a moment, but there is also a value channel, which we'll see in a second. So the queue channel, this is what's called an asynchronous, unidirectional, first in, first out queue. And it connects either two processors, or it connects operators. What does it mean? So asynchronous means the operations are non-blocking. Unidirectional means the data flows from a producer to a consumer, so essentially one direction. First in, first out means that when an element is, for example, emitted from one process, you can be guaranteed that that will be the one that is received by the input of the next process. So the order is preserved in that way. And the kind of most basic ways that we have for creating a queue channel is using this ChannelFactory. So channel factories are ways for us to construct channels. We saw in the example above that we used channel.from. So going back up to our first script, we had in the getting started with Nextflow, the first script we used what's called a channel factory. We created a channel called greeting channel from a parameter. Our parameter here was simply a string. So we have a couple of ways of building these channels, and we're going to go through some of these channel factories together. The most basic one that we have is from. So channel.from, and this is just simply creating a channel from the elements that we have. I want to look at the snippet here and just show you a little bit about what's going on here. Let's see. So I said with Nextflow, it's just code, so we can execute any of this code as we like. You can say Nextflow run hello. When we run this, we can see a couple of things here. So the first instance of this is actually using the Groovy function. So this is saying Groovy print line, the channel itself. So this is what the channel is. Whereas this here is actually an operator on the channel that we've just created. This is like you can think of this as like a Nextflow function on the channel, because the channel is a unique Nextflow data structure. Whereas this is telling us, okay, what's the underlying data structure in Groovy? And you can see that a channel is a data flow queue in this case. So this channel here is a data flow queue. It has some data flow variables here. So this is the first data flow variable, which is the values. So value 1, 2, and 3. And then you'll notice it has this thing on the end here called a poison pill. This is essentially an element in the channel which is saying, okay, the channel is finished now. Now, I mean, this is very rare. You would never really need to go into look in this into Nextflow, but it's good to understand exactly what data structure the channel actually has. What's much more important to us, and what we use much more often, is the actual operation on the channel. So for example, channel.view, which is just simply the contents of the channel that we had. Okay, let me just copy this up over here. So the first one that we have is a built-in print function for printing the channel variables, whereas the second one is actually a method that we have on the function itself. Now, another thing that we said yesterday about the use of channels twice. So if I was to, for example, take this one here, we're going to take the channel, the same channel we just created, and we're going to try and use it twice. We're going to try and take that channel and perform two operations on it. Now, what you'll see in this version of Nextflow, and what was originally sort of strict definition of data flow programming, you cannot consume a channel twice. So this means that you cannot perform an operation on the same channel twice because the elements have been consumed inside of it. This means that we can't, for example, use view in this way. Now, there's a provision on this, is that the latest versions of Nextflow, which will be coming out in a couple of weeks, you're able to do this. It's essentially, we've built in a kind of look-ahead mechanism for being able to duplicate the channel on the fly. But for the strict definition and for previous pipelines, you'll see this. You'll see that you cannot use this several times. However, there's a difference. There is also what's known as value channels, and value channels can be used several times simply because they are only a single value. So to create a value channel, instead of using channel.from, we can define it with channel.value, and then we can perform this as many times as we wish. So in this case here, I'm going to define a channel that's going to contain hello, and I can define this and use this 3 times here. Now this can be useful, for example, if I just wanted to have a file that I wanted to use, simply define it once, and then I can use it several times. So I'm able to, for example, as I said yesterday, have a reference file that I want to use and align against all my samples against it, for example. So that allows you to simply define it once. The value channel can be used many times. We can see that here. Okay, so let's look into a little bit more specifics of the channel factories themselves. So the value channel factory, it can be used to create a single value. So this is a way of simply saying it can have a empty channel. So we could say channel.value with nothing in this, and this would be an empty value channel. We have a channel value which can just contain hello there. In this case, the value of that channel is just a string. And we can see in this third case, we can even put a more complicated data structure, in this case, a list. And this list object is emitted as a sole emission. So what does this mean? This means that this channel here, let me take this out. We're going to rename this 3 to be clear. So this third channel here is not emitting. If we were to do a view on this, so channel3.view. It's kind of obvious in the first case what's happening. There's no value in there, so there's no elements being emitted. In the second case, there's a single element being emitted of hello there. And in the third case, no, it's still a single element which is being emitted, and it's just that that single element is a list. So before I jump into the Q channels, there's just a couple of questions I'll go back and get. So there's a question. The first one is, in the example yesterday of the hello and world, the order is not the same. Is the order then only preserved over the pipeline execution and not dependent on the order of the factory input? The order is preserved inside the channel, but not between the processes. So the processes are running completely in parallel, and therefore the determination of that would not be based, would be determined on how they are processed. For example, if you have one task which takes 10 seconds, the other one takes 9 seconds, then of course the one that takes 9 seconds is always going to be produced first, and therefore will enter the downstream channel next. Another question there is around the native GPARS. So these data flow objects are part of a library called GPARS, and because this is pure Groovy, which is a Groovy, it's a kind of a project for doing parallelization in Groovy, and you can look into the documentation there and use any of those things to look into those objects themselves. Okay. Another question is around, can we use this is a channel.value hello.world. So I'm going to copy the question here and place this into my chat. So imagine that we have a situation like this, where we had channel.value. So now we're defining two elements inside there. Never actually tried this, but we can see what happens here. And it looks like that you're not able to do that. So let's just check, confirm that that is the case. So I think the channel value there, the channel.value is expecting a single argument because it can only have a single value inside a channel. So what we were passing to it before is two arguments, and therefore it's not able to do that. Okay, final question on this is, can we subset the channel 3 to only print 1? So could we, for example, in our example before, take channel 3 and then print only the first value here? I'm not sure about that, because the channel itself has that value. You would have to just do an operation on that, which we'll come to later on, which is just a standard Groovy way of manipulating a string, which you could access for sure. But I don't think strictly from a Nextflow perspective, that would just be a simple Groovy, a Groovy expression. Okay. If you're interested in that, you can, on the left-hand side, down there, you'll see information on how you can, it's a kind of a basic primer on Groovy syntax. Okay, so value channels are useful, but they're relatively basic. So they can kind of hold these very basic objects. More interesting for us is queues. So for example, in this case, we want to have a queue channel. We've seen before that we can use this syntax here. So we're now going to create a queue channel which contains 4 values. Paste them here, 1, 3, 5, 7. Now when I run this, notice that there's something slightly different here around the view channel. So we can print this now. We know that it contains 1, 3, 5, and 7. Notice that if I was to change this and I was to say value and do it here, and I would have to pass this as 1. So this is the kind of contrasting with what we saw before. Now we've got a single value inside there. So let's say a string. Going back. So what we have when we have from is we have 4 elements inside our channel. And instead of here, what we have here is a closure. So this is a way of actually manipulating the function of view. This is a short way of writing this. So this is the function that we're going to perform this method on the channel. So we can do a view on that. This is an optional way of modifying what view is doing. And the key thing to note here, we'll see this a bit later with the closures, but this $it, so IT is a special value. You can think of it like item. So it kind of means value and then print view the value and then view the item itself. So $it, which just replaces that inside there. So I could delete this here and you'll see that we just get the element itself, or we can modify it. We can modify it like this. So sometimes you'll see on these operators later on, these closures that we can place on there. What we see before though is that there's a slight modification to the language that's happening now, or addition to the language, is that the way from is going to be deprecated to using of. And it fixes some inconsistencies that we see in using from. And it's really around the use of lists. So if we have of, we're able to do some more slightly sophisticated things. So we can say, for example, imagine that I wanted to create a channel which contains every chromosome and X and Y. I could use of here, and I could run this through. And then now it's going to contain our 23 elements, 24 elements, 25 elements. They're each of the chromosomes that we have. If we were to do something like from here, it's not able to handle lists in the same way. We can see this in this example here. So from list, is able to take that list itself, and then it creates an element for every value in the list. So for every element, sorry, for every value in that list, we create an element in our channel. So imagine that we had a list hello and world. If we were to create it in this way, run this through, we see that we get hello world, 2 elements here. If I was just to do from, I'm actually going to get, in this case, hello and world. If I was to do of, you can see the difference here. So when I'm doing of, I'm able here to create a single element of that list, whereas from was actually flattening that list, and that's not really consistent with what we want before. So using of provides us with a much more consistent way of doing this, and then we can simply say from list if we really want to create every element in the list. Just notice the brackets here. It's just a subtle way of handling these in a more consistent way. So channel factories are useful in this way, but what we've seen so far is simply values or very basic data structures. We could have strings, we could have integers, we can have lists, we can have dictionaries, etc. But what we're typically dealing with in genomics and these kind of data structures is files and files themselves. And files have some different properties than values, and they need to be handled in a different way. And the reason for this is that when we start to deal with files, we have to consider other things, particularly in distributed systems. So if my compute is in one part studying on my laptop and then the next part is running in the cloud, it's easy enough to pass a value around. It's simple enough to pass X, Y, Z around to the different distributed system. However, when I start passing files around and start particularly larger files, I have to handle them in different ways, because the way that someone uses a local file system versus the way that a system deals with an object in S3 is completely different. And therefore, in Nextflow, we need to create our files as file objects, as a particular type of file object, which Nextflow can then know how to deal with in different situations, for staging, for example, or for creating symbolic links, which we'll see in a moment. And the most common way of creating these file objects inside of our channels is to use from path. And the from path factory method can be used to do this. So this example here, we can create a channel using from path here. I just check exactly where we have this. There may be an extra. Let's have a look where I've got some data here. I've got some. So I've got, in this example here, I've got 6 files. So 1, 2, 3, 4, 5, 6 of these gut, liver, and lung samples. These are fast queues, and I want to put them inside a channel. So I've just done an ls on this data directory. If you're following along on the Zoom, you'll have the same thing. And then I want to do FQ. Now, we have a way here of using this glob patterns so that we can take everything that matches this. This is very similar to in Bash when you're just doing the matching of your files. And what this will do is it will create a channel with every fast queue that we have in that location. And then let's just view this. Note that the indentation here as well is not important. It's just stylistic. So I'm going to save that. Now let's see what we get. We run this. So in this case here, you can see that we've created a channel which contains 6 elements. And each of those elements now is actually the full path here. So it's the full path, not simply what we place in here. And this will be important later on because it allows Nextflow to actually access that file independent of where it's working, where the working directory is. We can't rely on relative paths, particularly when we have distributed systems in this way. We also have options here on how we can import these files. So instead of, in the first case, you can just see that we have a single argument here. In this case, we had, in our example, we had data ggals.fastq. So we have a single argument here. We also have options on this. And when we look at the options that are available, you can look in either the Nextflow documentation, or this is an example showing the options that are available from Path. You can see that we have several considerations here. We can use the glob patterns, which is what we're using here. So this is to interpret the wildcards, for example, or we'll see in a moment how we can handle multiple files. We can have ways of the type of the path return. So this could be whether we're looking just for files or directories or any of these. We can consider whether we want to have hidden files. So is it going to search for and include hidden files as part of this? And we can also consider the maximum depth. So how deep in terms of the directories do you want to go? By default, this is going on. So to place any of these options, we can, for example, use like this, and we just place a second argument here where we write a comma, we write the option, and then we want to know if we do this. So if I was to, for example, create a file here, so I'm going to touch a file inside data ggl, and I'm going to call it, I'm going to create a hidden file, like gut3.fq in this case. Now, when I run this, you can see that by default, this would not be picked up. Save this, run here. We're going to get 6 files here, and then with some luck, here, we should now get our hidden files selected in this way. And you can see that now we have that hidden file was created. So this is options that you can do it. You'll see that through the Nextflow documentation, all of the options that you see, particularly around the operators that we have, there is many options, and kind of getting familiar with that and how to read them and how to use them becomes very important. We'll see some more practices, so we'll do some more practice on that later. Okay. Another important channel factory we have is for dealing with pairs of files, and not simply pairs of files, but situations where we need to create groups of files based on some criteria. The very typical one for doing bioinformatics or for doing reads is, for example, when you have 2 reads, _1 and _2. Here, you typically want to process these as a pair. You want to have them as they are one sample, they're just 2 files of that one sample. And in doing this, we want to be able to match them based on some common key. In this case here, you can see that this is some SRR, so you can see that this is the common key between the 2 files, this part here. And then you have _1, _2, etc. So we can do this, and we can create a channel which contains these elements using from file pairs. I'm going to continue my example as before. The other thing to note, though, is that we have the part before here, which is the common section. Essentially, this is what it's matching for. And this star defines what that is. Then you have underscore, and this 1, 2 means that there's going to be a file, or it's going to look for a file with _1 and then _2. So this is kind of typical blob expansion. I'm going to take this from file pairs option. Change this here. I'm going to have to do underscore exactly as we had before, 1, 2. Let me just remove this file, because otherwise I go through the examples and... Okay, so let's save this one and run this. you'll notice something different's happened. We've managed now to have a channel, but the channel only contains 3 elements. Instead of having 6 elements, we have 3. And each of those elements has a different data structure compared to before. So the data structure is now a sample ID, which is the matching pattern that we had. And then it's a tuple or a list of these files here, of the lung _1 and _2. Now, how did we know that was going to happen? Well, again, this comes from the Nextflow documentation here. So if you were to read what's happens here, I'll just pull this up. Nextflow docs. So how I would do this, I would go on the left-hand side, I would see channels. I know that we're dealing with channel factories here, and I can see that the one that we're using is from file pairs. So by reading this, you can see exactly what has been emitted from that. And the example here is the same, but we say the from file pairs method creates a channel which emits the pairs of files matching a glob pattern by the user. So the matching files are emitted as a tuple, which the first element is the grouping key, and the second element is the list of files. So we would know that this is going to return, all of these have examples, the matching key, and then the list of files that we have. And this is going to have some important consequences downstream when we want to use this channel. We want to be able to take this and now use it in a process downstream. We're going to have to know what the structure of the channel is. We also have a series of options that we can run on this. So exactly the same, you can read this here or in the documentation. If we look here, for example, it's written in the exact same way. Let's take and see if you can do this as your example here. I'll give you just a moment. What I want to do is we want to take from file pairs. I want you to run it on the same data set here. So from file pairs on this. And I'll just give you a minute to add into here. I want you to use the check if exists option. So we want to see if the file actually exists. And this is a really nice option for basically some simple error checking, some sanity checking. Did I actually provide it with some inputs? Okay, so we can go through and look at that option there. So we can do check if exists. By default, this is off. So this is not on. It's false by default. We can do check if exists, which is the semicolon, and we say true. Now, for example, if I made a mistake in my script or in my input, the first case I can run this through. I can see that I get the 3 samples. If I made a mistake and I forgot that I called them fastq, common mistake, something like this. When I run these through, I'll get an error that nothing matches. 2 questions have come up from this. So one of them is, how can I match files from 2 different channels? So imagine that you had assembly from channel 1 and the 2 read files from channel 2. We would do that by combining the channels with a channel operator. We will see that most likely tomorrow, how we combine channels. For now, we're just focused on the actual creation of the independent ones, but you can look through the channel operators, for examples, if you're interested. And what would these channels be called? So the channels themselves, we can actually assign a name to it. So in this case, we're not assigning a name. But it's true that what we should do would be something like if we're going to use this downstream, should be something like reads, in this case, like this. And then we could use, imagine that we called this, for example, reads channel. And then I ran this, fix my errors. If I wanted to use this downstream, say I wanted to perform an operation on it, or I wanted to use it as the input of a process, I would do, for example, reads channel, and then I can call it. I don't have to chain all of these together. And there's another question. A common situation: you have more than one fast queue per sample. How would you deal with that? I would still keep them probably like this, and I would add another. I would add another variable. I would manipulate the channel to have some kind of common, to have another key which I could base that on. It's probably not in the ChannelFactory. I would do a modification on the channel itself, because if we look at here, for example, if we ran this, we'll see that this is creating something here. So this is, for example, lung, etc. Imagine that you wanted to have lung sample 1, lung sample 2, lung sample 3, etc. You could create and modify whatever's in the channels that you have here. You can add another key, essentially, which you could then use to merge things on later on. Another question is, how would one access the first element of a channel? Typically, you shouldn't iterate over a channel. So we shouldn't perform operations like that inside the channel. The reason for that is that what we were saying before is when you consume an element from a channel, you are essentially reading from that, and then you can't actually access it later downstream. But the Groovy operators will help you there if you do need to do that. Another question is, for more than 2 files that match a blob pattern, for example, 1, 2, and 3, which files are paired together? So this comes down to, I think this is related to here, where we can have a size. So this is, as I was saying before, it's called from file pairs because we're typically dealing with pairs of files. However, you can match this with any number of files. So you could do this with 1, 2, and 3. If you needed 4, 5, you could set to any using -1. And this is useful, for example, if you have some that are paired in, some are paired and some are single, and you want to capture all of them into a size. So kind of writing a pipeline, which is a little bit more generic. Another option I think that we just noted quickly is that it depends on the structure of the channel. So look at flat, for example. I'm going to remove check equals exists just to make this simple and just so we can see all this together. If I was to use here and just look at the default version here, so just running this straight, notice where the square brackets are. So this is producing, as we said, a tuple with a sample ID, and then the second element of that tuple is a list. If I was to do here and say flat is true, and then view this, what we'll notice here is that now the second one here is no longer it's no longer now a tuple that contains a sample ID and a list of files. It's a sample ID and then a file and then another file. So this is no longer a nested list in here, and that can be useful for if you want to access them or manipulate them in a different way. So we have ways of controlling the data structure inside the channel as well. And this can be done in this case when we're creating the channel, but it could also be done outside. Okay, there's a few other ways of creating channels as well. So as I showed you in the documentation we went through, one of them that could be useful is for querying the SRA. So this is a sequence read archive. And in this way, we're able to provide accessions or even keywords. And what we're able to return here is a file object. And notice that this is now a remote file object. So this is how Nextflow is also able to handle remote files. So in the first case, this may be a little bit long, depending on the usage. But what this ChannelFactory is going to provide us with is the sample ID that matches these ones and these files, and then the actual files themselves, which are FTP. You should actually define a key if you want to do this with any sort of speed, because there's a restriction on the lookup. So it's slightly slow to pull this through. But what we see here is that those files now, some of them are sample ID, so the sample ID here, and then some of them are a list, some of them are singles. I'll just close that, doesn't go through. But the point is that these are now full FTP paths that we can then use downstream in our processes. And when we do that, Nextflow will know that they are remote and able to be able to pull them to the location where the data needs to be run. Okay. What would that look like? So imagine that we wanted to do the same thing as before. So I'm going to take what we have before, and now I want to use this. And now I want to use the downstream processes here inside a process. So I want to use the channel, sorry. Oh. Okay, we're still online. I wasn't sure, I said some weird thing with my computer. Okay, imagine that we wanted to do fast QC on these. So we want to define a input. And now we can start to see how the process is linked together. So I'm just going to use the same bit of code here. I'm going to first define a parameter. So we're going to create a parameter called accession. And I'm going to provide it with a default value. I'm going to use the one above because I think it's slightly quicker. So I'm going to provide it with a default value of the one that we were just able to pull. We then create a channel called reads. This reads channel is using the accession, which we're defining as parameter. Because it's a parameter, we can use it and define it elsewhere on the command line or in our config, for example. We're then going to have a process here. Our process is going to have an input. And the important thing to notice here is that the input slightly changed from the version we saw before. And the reason for that is the structure of this channel. Let's have a look again. If I was to save this, run hello. Oh, that's very obvious. This gets stuck running in the background. What I want to do here is shake this one. Let's just start a new terminal. Okay. What I want to do here is we want to define some input. Let's just call this some path. We're then going to use that now inside of our process. So I'm going to build this up slowly. We can get it from before. Let's call this reads. And we're going to use the same reads that we had before. So those reads were, remember, they were in data, gggal, and then we had something called this. So we had the name underscore something. In the first case, I'm just going to use one, gut underscore 1, 2. Exactly the same as we had before, and then we had dot fq. So we now have a parameter which we've defined. We're going to create a channel from that parameter. So we're going to say reads channel. It's going to be from file pairs. And we can use now the parameter we're defining as the input to it. Let's just first do let's just do a view on that. So I'm just going to view the contents of that while we build this up. And what we're working to here is how we can define and how we can specify the process itself to match the structure of the channel that we create. Okay, what are we doing wrong here? This should be channel, sorry. Okay, now notice the structure of this channel we've just created. It's a tuple, which contains a value, gut, and then the pair of files. If we look at the example here, what we're going to set up here, in this case FastQC, the structure matches this. So the structure here, the cardinality of this channel has to match. So when I have a process FastQC here, the input has to match what we have. We have a tuple, which contains a sample ID. This is shorthand for writing a value here. So this is just the same as saying a value. And then we have some files from a reads channel. Now, notice that these can be anything. Whatever we specify here, this could be X and Y, however we like, but we're going to use those as variables later on. We're going to use those as variables later in the Nextflow process. So key points, whatever the structure of this channel is, has to match where we use it. The cardinality has to match. It has to be a value, and then it has to be some files. Because we have a value here, and we have some files. Okay, let's cruise this down. I'm not going to run FastQC, but I'm just going to echo something here so that we can see this. Let's just say echo our Nextflow variable. So we use a $sign again, sample ID, into some file. Let's call it sampleid.txt. Okay, so now we're going to be creating a file called sampleid.txt. I can then specify this as my output. I'm not going to go into the full details here because we'll see this in a moment, but this is going to be sample ID text, and then we're just going to put some curly brackets in here to specify that that's the variable. This is going to be now our downstream process. So when we run this, some luck, we should get this running once. Okay, there's a mistake somewhere. Okay, this is a variable which has been check this. Something's somewhere wrong. Come back to this in a moment. I'm trying to, I can't see my problem here. I think it's here. That's right. I need to do the same thing on this side. Okay, so I was not specifying that there was a variable there. So what we do when we run this is that this will run once because we're just specifying the gut sample. Some directive here. Oof. The key point here is that when this matches this will run once for the sample that we have. I'll come back and see that in a moment, exactly what's going on with that one. Okay. So I think we'll just start on essentially on the process block, like what we just saw, for 5 minutes or so, and then we'll take a break. Okay, so the processes are the core building blocks of Nextflow pipelines. They're essentially the things that define the tasks, what is being run. And process blocks can start with very simple, can be very simple. They start with a process, the name of that process, and then we have some curly brackets here. The most basic example of one would just be where we're defining the script section like this. This means hello world will just be run inside our process. So we can run simple Nextflow process. We don't even have to define inputs or outputs in this case. Let me just come back to that later on. So we can say this, let's just save as. Create that there. We can run this now. And we can see that this process will run only once. By default, it runs once. It's running locally, and we're getting hello world. The full syntax for writing a Nextflow process can be seen here. So here we have the process name. We have some directives, which we'll see in a moment. What we've already seen before is the inputs. So we have the process inputs that we define. We have the outputs of the processes. We have an optional one for setting a condition of when this runs. So when the process is executed based on some condition which gets evaluated. And then we have the script section. So by default, we have a script section. So this is the structure that it should have. It should be in this order as well. How many of these we have to define? So we can have 0, 1 or more directives. So this is essentially optional. Same with the inputs is optional. We do need to have a command section though. So the output is optional, when is optional, etc. The script section. So the script section is the main part of our process. And you can see that we typically use these, this 3 signs, that's the 3 apostrophes here, sorry, 3 quotes here to specify what's going inside that. And by default, this will be running in bash. So anything that we have here, if we don't specify what it is, this would run in bash. So I would say, for example, here, take this out, paste this in here. I'm just going to put echo commands on here because I don't want to, I don't want to actually, I don't have Blast installed, actually installed on this machine, run this, and we can get this going before. Okay, so this would run. Another little trick here is that if we want to view the output of a process in the command line when we run, is to use process.echo. And what this does is it simply, this is actually a directive or a kind of config for a process and allows us to view this. This is useful for debugging, but I wouldn't recommend this for your actual run. If you have more than 1 or 2 processes or tasks running here, this would end up being not very easy to follow. But for teaching and examples, it's quite useful here. So we're able to actually output what we see. Not sure why that hasn't worked. Okay. We were outputting through the files. Now here we see. Should see this now. So this is the output that we've been created there from that script section. And the script section by default is, as I said, is in bash. This is just a command line that you run. However, we can run all sorts of different scripting languages here. So imagine I wanted to create now a Python script. So I could create a process. I'm going to call it py stuff. I have to define here the shebang line. So this is now saying, okay, instead of using bash by default, we're now wanting to run with Python. And now anything I have in here in the script section can be Python itself. If I, for example, wanted to say here, I think that this may be a slightly different version of Python. So we might want to say, just do this, put our print within brackets. When we run this, you can see that that was actually now Python that we ran inside here. And the same thing could be for any language. So anything, any scripting language where you can put a shebang here. So Perl, R, etc. Anything that you can run from a script can be run inside the Nextflow, inside a Nextflow process. This can be useful. However, it's not typically something that you want to put in a huge script. And so if it's like more than 20, 30, 40 lines in here, it's better to externalize the script itself. And we'll see that later on today. But typically you'd want to put that into an external script, and then we can run that. We run that and call it from outside there. So before we go on to parameters and how we can use those inside of our scripts, I think we'll just take a 10-minute break here and join you back at 35. Okay, jumping in from before. Earlier on, I had left out the quotes here, so you can see that section in the string interpolation. We'll see later on, but it's important there to have these quotes here. There's some questions about can we use the inputs of a channel inside of our Python processes now. So this is a question around how we can do that. So imagine, I think this is the example, but we pointed out if it's wrong. Imagine that we had as an input section here. I don't have pandas installed, but if I had, say, something like file, my CSV, this was coming from my CSV channel. And then how would I use this file in, for example, pandas? So imagine that I had my Python here. I can get rid of this. I would do something like import pandas. And then I would be able to do d dot, I think. So it would be dot read, it's called CSV. And now I can just use that input here. This is now a Nextflow variable, which is a file inside my Python process. So that should be able to do it. And we'll see more of this pattern that you can use later on. Very much related to this is now how we can use parameters inside these scripts. So from the material here, you can see that the most basic way, we could define a single parameter here, in this case a string, so world, and we can use it as an input. Actually, we can just use it as a parameter inside of our script here. So this is very basic. And for a string, this works fine. You could just simply say parameter world. Note that there's no data flow programming happening here, though, in the sense that the only thing that's occurring here is that we are printing this. This is just running once, and that we're printing this again. I'm just going to move back to process.echo equals true, process echo, so we can see the contents of our processes and what's actually being printed there. Okay, so that's easy enough, but note that this is now a Nextflow variable. So this $ is Nextflow variable. Imagine that we were running some bash and we wanted to actually use a bash variable. So we wanted to use the $ as well. Okay, so consider this example here. Imagine that we wanted to use the pwd variable, which is a bash variable. Well, we would have to escape this now, because otherwise what we're going to be using is the Nextflow variable. So we have to keep in mind that we are mixing programming languages here. In the sense we're mixing what we want to execute inside of our script section, as well as the Nextflow variables, which need to be interpolated. So let's take this one here and run this. This is now the bash variable. And therefore, because this is the bash variable, you'll see that this is printing out the whole working directory where that task is actually taking place versus, say, the actual location that I'm running in now. So this is kind of showing you that the task or the section inside that script section is being run from the full working path, from the working directory of that individual task. So remember from yesterday, we have this hash, which is made up of the inputs of the task. This 910C is the working directory for that task that we're running there. What happens if we want to mix them up, though? What happens if we wanted to use several of these? Well, in some situations, it can become a little bit tricky when we have many of these bash variables or any scripting variables that we want to have inside of our script section. So one way of doing this, when you have a lot of them, is to use the single quotes here. And when we use the single quotes, we no longer need to escape these. So now the path there can be used directly. So if I was to show you this through this section, when we run, we're able to actually access this. So we can see that this is the full path of this machine that we're running here. I could do the same thing with PWD now. This here. You can see that now this is the actual bash variable just by changing these quotes here. We may also be in different situations where we want to mix these up in more complex ways, where we want to use both bash variables and Nextflow variables, and we don't want to escape them. So the situation for doing this is now we change up the shell definition. We don't want to longer use script. We want to use shell. And with shell, what this allows us to do is specify that our Nextflow variables are no longer denoted with a $, but with an exclamation mark here. So in this case here, I'm going to define a parameter. Let's define a parameter called lemon. This is its variable name called data. I can now define a bash variable called bonjour, and then I can echo this. And when I echo this, notice this is the bash variable, and this is the Nextflow variable. So I can mix and match them using this shell section here. You can see how that works. Okay. Because Nextflow is just a pure a DSL, we can also access the underlying Groovy inside of the script section. So we can do, for example, conditional inside of that script section to determine which is to run. So we could have multiple commands inside of a script section and then use Groovy to determine which of these was actually be executed. In this case here, imagine that I had a parameter which was defining which process we would execute. So I'm going to take here my processes before. I'm just going to put some echoes in here. So by default here, we're going to be saying if the parameter is Callisto, it's going to run this. Let's just do an echo in here. If the parameter liner is salmon, I'm going to run this one. And if I make a mistake, I can even throw in some more complex logic in here where I could define this is a Groovy illegal argument exception, which you can throw there because it doesn't know it. So to combine this, let's save that. You can see here from the script, we're defining the Callisto is the default. So by running this with default, we should see echo Callisto here. Exactly like this. Remember that we can change parameters from the command line with this double dash, so double dash aligner. If we then call this aligner, for example, salmon, get salmon being executed here. And then if we made a mistake because we called it something else, we would get an exception. So you can see how we can now use and how it can be powerful to have a not necessarily specified design of this, and allows us to handle corner cases more easily. Okay. So that was the script section and the shell section for defining the exact processes, or defining what actually gets run by our processes. But we can also define the inputs, and we saw this a little bit before. So Nextflow processes can be thought of as always active. I like to think of them as sort of little machines that are just waiting there for the right input to be received. And when the input is received, they are executed and the task is like triggered to begin. So in this case, imagine that we have a very basic process which has a single channel as an input. And that single channel would contain single files. Each of those files, when they are received by the process, so when the channel emits them to the process, each task is executed, and the task inside the script section, which we just saw, would be run. And then we're going to capture the output from that if that is defined. So the way of writing these inputs is that we have an input qualifier. This could be, for example, the type that it is. So we have values and we have files typically, which we also use for path. We then have the name of it, which is a name that we can give. We are essentially defining what the Nextflow variable is in this moment. And then we say from the source channel, the channel that it comes from. This is best seen from an example. So the value qualifier now allows us to receive any data type. This is typically, you would use this for values, so for strings, for maybe lists, possibly even dictionaries, etc. And you would say the value we're defining as X is coming from a channel called num. So we define the channel contains 3 elements, 1, 2, 3. Write this process and we say that the value X is coming from here. Notice that this X now is a Nextflow variable, and we use the Nextflow variable then inside the script section using this $sign here. So echo process job X. The other key thing to note is how this is run. So I'm just going to close this. Get rid of this. So now let's run this before. The important thing is that you'll notice that it was not saved. Okay, third time lucky. You'll notice that because the channel contained 3 elements, in this case, 1, 2, 3, the process was executed 3 times. We got 3 tasks being generated from that process. Job 1, job 2, and job 3. This is why it's so important to be able to control the contents of this channel. Okay. What about for files themselves? So we saw above how we can use a value, how that can be run, and how those would then be executed in parallel. What about files themselves? Well, we can think back to the ChannelFactory we used before. So we had this channel from path. We're defining some reads here. And then we can use that as an input inside of our process here. So let me take this one. It doesn't change much here. So you can see that we're only really changing the fact that we have value. Now we have file instead of value. So this is the key thing which has changed here. Again, let's put an echo here. So we are going to define our channel. If we remember before, this has 6 elements inside of it. So sorry, this has 6 files which will match this pattern. Therefore, we'll get process foo will run 6 times. You can see that there. What you'll notice here, though, is that something different happens. We are now, instead of assigning this as a Nextflow variable, we are defining it as a string here. We are saying that this file will have this name. And something's happening in the background there. Before, if we define this as a variable, Nextflow will use the actual file names as we saw before. Now we're actually defining this as a sample.fastq, and each of the samples now will be called sample.fastq inside that work directory. So there's several ways of defining this, and we'll see the example here. In the first case, notice that it's sample.fastq. Each of the files then will be imported to that working directory using sample.fastq. We could also use this as a Nextflow variable. We could also say in sample file sample here, and now it's a Nextflow variable which will use the original name. So contrast with what we saw before. Notice how that we're having your commands, reads, and each of the 6 samples now is called sample.fastq inside that work directory. I'm changing, the only thing we're changing here is this sample now to not be a string, but to be a Nextflow variable. We run that. And you'll see that we have now the original names that we have. So let's put an echo on there. We have the original names from the samples themselves. So we have gut, liver, lung, etc. So this is just an option that you have when you import your files into processes to define whether you want to rename them essentially as before with a string, or you want to keep the same name and use a Nextflow variable to take over that name. Okay. There's a couple of questions. We'll take a pause here and try and answer some of those. If I want to use a channel as an input to multiple processes, is this where we can use a value channel? So that you could, we'll see this in a moment when we have multiple inputs, but you could use, for example, if there was a value channel that you just had a single file that you wanted to use as input, and you wanted to run it against another channel, which contained many files. This is when you would use the value channel. And then there's another question. In the triple single quote syntax, is it possible to access the inputs? Would that happen via the substitution of X or something like inputs.x? I don't think it is possible to access them inside this single quote syntax. I think that you need to use the double quotes for that, but Paolo will correct me if I'm wrong in the chat. Okay. Now let's consider an example here where we are going to do an operation on it. Before we saw we had flatten, which was flattening our channel. Now let's do an operator of collect. What this will do is going to take all of our 6 files that we have, so that the 6 FASTQ files that we have, and it's going to collect them into a single element that we can use. This may be useful, for example, when you want to change the composition of the channel so that you collecting all your samples, say at the end of an analysis, that you want to run one command over them before. And what this will do is it's going to take our individual files and create a list of files. And this sample now will actually be no longer a single file, but it will be the full list. And we can see here when we do this, that this process now, when it runs, sample now will be all of our files together. So let's change this again to echo, save this, and run this as one. We no longer will have foo that runs 6 times, but foo which runs only once. And we can still access each of these files. We can still access all of them. The key point is that now this process, and more importantly, this working directory, has all of those files in that location. They are being staged as required. They are accessible for the command to be run in that way. There's a question here of can we use this operation collect for grouping files as well? So could we group them on lung 1, lung 2, for example? Or defining the channel in a way that only defining the channel is the only way to do that. So we would do that with an operation, with an operator, that you would do these groupings. If you check out the documentation on operations here, which we'll look at this tomorrow, but you'll see the operators you would be combining these, and you can do merges, concats, collects, combines, etc. Based on this. This is why we still just start with the basics of how we can create them. Okay. Another one. Another thing that commonly I see people make mistakes in Nextflow is to take, for example, a file that they use and they just use it directly without passing it into a channel. Now, this can be sometimes this can work specifically for a value channel. The previous versions of Nextflow weren't able to handle this. So, for example, take this idea. Imagine that we're just defining a genome, but we're not specifying that it's a file. So In the first case here, this looks like a string as far as we're all concerned. This could be a string. We don't necessarily know that this is a file. What happens if we paste this in here? It's important to keep note of what you have in terms of your input. Are you specifying that it's a file using from the channel? There's also a special helper function though. So let's consider here, save this, run. Again, echo command here, let's launch. Notice here that this is now called input.1 because Nextflow doesn't know that that is a file itself. So as far as Nextflow is concerned, that would just be a string. So Nextflow is expecting you to put value here, the actual value of that string. Now, you could try and do this, like I'm showing you here. But in the end, what we've got here, you may have this, but this is still a value. This is still a string. If we were to go into this working directory, so ls on the work, on the 3f, 28, etc. Notice how this file is not in the working directory. However, if I had created either a channel, so if I had said genome, say I had said genome channel equals channel dot from path, and then I had provided it with params.genome. In this case, if I had params.genome here, now if I defined file from genome, I want you to notice the difference here. This is what I'm always trying to get at before, the difference between a file and a value. So now we still have the transcriptome as we had before, but if we do it now in ls on that working directory, so work 6023, notice how the transcriptome file is inside that working directory. It's what we've called, it's been staged into there. And this is very important if you run a distributed system because you need to ensure that the data gets to the for example, the virtual machine or the location of where you need to run the data. So this is why we are this is why relative paths get fully extrapolated to the full path, and why we need to take care of what type the object is, whether it is a file or whether it is simply a string in this case. Now, another way of doing this, instead of having to write this genome channel equals channel, and it kind of looks a little bit repetitive, in the latest versions of Nextflow, instead of using file here, we actually have path. And path contains a helper function for automatically doing this conversion for you if you define your input as a file. So if I change this to path, for example, and now I had path genome here, notice that I've removed this channel. I could actually call this directly. And all that's happening here is there's a helper function which is saying, because you're writing path, I'm going to convert that for you into, in this case, because there's just one of them, I'm going to create that into a value channel. So I could use this params.genome in several places of my, several locations. I think that file doesn't exist. Let's have a look. What's wrong here? Check what the documentation says. Okay, I should give it the full path here. So another thing that we can use to provide this full path is this base dir, and this is pretty useful for, and I would highly recommend you doing this, particularly when you start to run your things, for example, from GitHub. So by using this base dir, it's providing the full path of that location, and it makes it independent of where we run the pipeline. Sometimes the pipeline will be pulled from GitHub, placed into your .nextflow directory, and then run from there, in which case the, say, test input data in this case would not be from where you run the pipeline. So this base dir is a kind of project base, which we can use to do that. So let's close that one there, save this, and show you that this works as before. Okay, it's because I don't have the commands. We get this launching there. Okay. So I would recommend, so from, as I say, from the version of October last year, you'll still see a lot of old pipelines with file in them, but I would recommend using Path from now on because it's just able to do this automatic translation of the string values into file objects. It just makes it a little bit more robust, your pipelines. Okay, now for the combining of the input channels. And I think there were some questions before on this. How would we essentially run with more than one input channel? It's not very rare. It's not very common that you're simply running with one input. You're trying to combine your data, do some analysis with it, and run it. So in this case, now we're going to define two channels. We could define them either here or we can define them outside. And I'll show you both just so you can get used to this. So I'm going to show you here. I'm going to create a process of foo. I can say, let's create a channel called the A channel equals this section here. This is just a definition of it. And then let's call it B channel, which is this channel here. And then we can say from. So you can see that you can define the channel as well inside the input section if you want. I'll split this out just to make it so you can see some more examples to make it clearer. Okay. Also note that this is a directive. So this is this equivalent of writing process echo equals true on the command line. If I place this here, or I can do it from the command line. The key thing to note though, what do we have here? We have a channel which contains 3 elements, the A channel, and we have another channel which contains 3 elements, the B channel. When I launch this now, we'll see that we get 3 executions here. We get 1 with A, 2 with B, 3 with C. Okay. And this is because if we think about it, the first channel here is just emitting at 1, and the second channel emits A. You can see that the process is essentially waiting there for the right inputs to arrive. As soon as 1 has arrived, as soon as A has arrived, it's executing the script section, just printing the contents of that. The next thing happens. Okay, kind of simple enough. What happens if I have different combinations? What happens if, for example, the cardinality doesn't match? So imagine that I have now, instead of having 1 and 2 and 3, if I just had 1 and 2, I had A, B, C, and D. Save this and launch. Now you can think that the process foo is sitting there, it's waiting. It receives 1 and it receives A, fires the execution. It receives 2 and it receives B, fires the execution. But then there's nothing more to happen. So the pipeline ends. If we remember from before, what's happened is it's actually received a poison pill here. The pipeline cannot complete this anymore. This process does not have the inputs to fire. This is really data flow programming in practice now. We can see that it's the contents of the channels which are driving the execution of the tasks. Okay. This is also where the value channel can become quite important. So imagine that one of our channels now was no longer a Q channel, but our second channel here was a value channel. So it was just contained a value 1. Now, remember that value channels can be consumed, the elements can be consumed multiple times. So in this case, specifically with a value channel, we can run this and we can get the combinations of it. So we get 1 with A, one with B, one with A, etc., all the way through. Now, look at this example here. Let's try and do the same thing, but we want to write a process that is executed for each read file, matching the pattern we saw before, and then use that data.gggal example. So let's try and put this more into practice. So let's consider what we had before. We now want to have a parameter. So let's just say a params dot transcriptome equal to the location of our transcriptome. You can find all of this data under data, GGL, etc. So we're going to have this as $base dir. This under, then it comes data slash transcriptome. Now, we want to do the same thing with the paths, right? And then we're going to say, so with the reads, so we're going to say the reads dot params. Let's start with the parameter. Params dot reads going to be equal to the same thing again, but this time we're going to use all of the reads. So we're going to say data star underscore brackets 1, 2, because we want to use these as file pairs. And then we're going to say .fq. Now, the first one here is just a single file. So we can use this as a value channel. We can use this just as once because we want to run all of our reads against that one. So for however many pairs of reads that we've got, we will do this. However, for our reads file, for our reads channel, we should create this into a channel. Also because we want to use the from file pairs. So we're going to say our reads channel equals from file pairs. And then inside here, we're just going to place the params themselves. Okay, we're getting there. Now we've defined the process. We're going to have two inputs now. They're both going to be a path. So the first case is going to be our path. It's going to be our transcriptome. And it's going to be from, in this case, the params.transcriptome. So because this is a value channel, Nextflow will be able to convert that into the path. It's going to convert it into a file object. However, for the second one now, we have to remember what this is. So this is a tuple with the first one, which is a value, which is our sample ID. This could be, remember, we could call this sample ID. We can call this whatever we want. And then we know that the second value there is again, the pair of files. So in this case, the reads. And we're going to say that it's going to come from this reads channel. Almost there. Now, final thing, let's print this so we can see this something out. So let's say echo align this chaos sample ID, a Nextflow variable, against, and then in this case, let's go a file, which is going to be transcriptome. Save that. Some luck, hopefully there's not too many errors in there. Oh, I forgot that twice. There we go. So I just need to specify the from file pairs as ChannelFactory. Launch that, and we don't have an input for some reason. I've forgotten gggal of both of these. So you can see that the pipeline went to run, but there was no input data which matched it. So the process began, and then it hasn't started up again here. Just trying to see why that's not the case. Transcriptome isn't spelled right in line 1. Let me just check this is right. I see. And I think it's probably transcriptome.faster as well. Yeah, thanks. thank you for that. Oh, still not having any luck. I see. I'm very highly dyslexic on this one. I guess I've spelled it wrong a couple of places. Let's get this right. Right. Okay. It's still not working for me. FQ. Let me just check on that. It's okay. We can move on. Cut that one out of the live stream. We'll fix that up. Fix that up tomorrow. Not sure why not. Okay. Input repeaters. So in this first case, we didn't actually go through all the combinations of how you would do this. So there's the question from before is that how would I run, for example, 1 with A, 1 with B, 1 with C, 2 with A, etc., 2 with B. And there's a couple of ways of doing that, but typically we would do this with an operator. We would combine the channels first to create the channel. So let's consider that when we look at the operators tomorrow. There's another slightly different way of running of defining an input where we don't necessarily use a channel, but we use a list. And this is useful for defining parameterization. So in the case here, imagine that we wanted to run tcoffee, which is a multiple sequence alignment program, and we wanted to run it with 3 different modes. We wanted to run it with regular, with espresso, and with ChannelFactory here. Imagine that we wanted to take each of the files that we have. So let's go back, check out this. I'm going to create a new thing so I can create a new file here so we can do this tomorrow. I'm going to say ls, just check that we have these files. So you can see that we have these 6 files here. These are just some proteins inside this protein directory. I want to then run tcoffee against each of those, but I want it to run with the 3 different modes as well. So this here, we define an input here, same as before, a path, which is just some sequence from the sequences. This is a channel we've created. And now the different thing is that we have this repeater. So this is saying each mode is the Nextflow variable we just created, from the methods. Methods here has to be a list. What this will do is it will create all the combinations of that we have. So let's save this as 2. We launch this now. Okay, nothing here. Wants to run for me now. Yeah, that's the wrong script. That's true. This one should be. Now, because we're using base dir, we should define that as a variable. Okay. Okay, this is what we wanted to launch. I'll just scroll to the top here. So what we can see is that we got the combinations. We had 6 files here. So that was the 6 different protein files. And for each of those protein files, we ran now with each of the methods. So 6 times 3 was 18. And we see that this echo tcoffee command, so the process align sequences, ran 18 times. So this is particularly good for if you want to do like parameterization of your pipeline, where you need to run against various different parameters. You can use this each mode quite well. I think the thing before was exactly, so I was using single quotes from the example before, but I needed to use double quotes because we used base dir there. So save that one. back and confirm that that's going to work. Okay, now you can see that we did align lung against transcriptome, align liver against transcriptome, etc. So the value channel was automatically created. And because it was a value channel, we could run it against our Q, against the 3 elements which were emitted from our reads channel. Cool, thanks for that. Okay, that's the end of the kind of input section in terms of how we can define the inputs of the processes themselves. So the most common pattern you'll see here is typically path with a file, with a variable you name from the channel you're creating. You also have the tuples from before. So remember that when we look at this example, the key thing that's tricked people up is remember that this reads channel has a structure, which is a tuple, which contains a value and some files. Other thing to note there would just be to remember that Nextflow is going to take the first value of each of those, of each of the channels as they're emitted. So you should structure the channel before you run it. Okay. Outputs are fairly similar to inputs, and the definition here follows the same pattern. So we have a qualifier. So this is value or path, for example. We define what the output is, and this can be thought of as what Nextflow is going to look for. So Nextflow is going to capture that, and that's going to go inside the file. And then we're going to say into the target channel. This is a new channel which is going to be created by Nextflow, and it's just going to contain the outputs of this process, which can then be used downstream. Okay. Let's have a look at the example again. Again, we're going to have this simple process. So we're going to define 3 different methods here. And what we're going to do is capture these inside an output. So the key point to notice here is that we're going to have a value, which is X. And this is actually, in this case, it's just the same that we have from before. We run this. And save. So it's going to run process echo here. We're not going to see anything here. This is not the echo of the process now. This is just what we're seeing. So the contents of the receiver channel, which we're generating, is essentially the same as the input because these values are the same. So we're just capturing the thing directly. It's not doing something particularly useful, just shows you how you can use a value in the output. What's much more useful is to capture files and how we can capture files inside these outputs. So take a look at this process here. This is a process which is just going to create a random number. So notice here now we're using the single quote. So this is a bash variable. We're going to just simply create a random number, place it into this file called result.txt. And this is what the output will be. So this is what Nextflow will do. What will happen is the process will execute. It will run. And then at the end of the completion of the process, so the end of the completion of the task, sorry, if there is an exit code, which is 0, Nextflow will say, okay, is result.txt here? If it is, place it into this numbers channel, which we can then use downstream. Let's have a look at this. So when I save this here, we don't need to see the process anymore. And we can see we can view some random numbers, which is generated from bash. Okay. Sometimes it's useful, though, to have, for example, multiple outputs. We saw that in our example before that we saw what chunk can do. So chunk can create multiple outputs. We can also capture these multiple output files using a glob pattern, so using a wildcard to capture these. And if we look here, taking these, now if I run this, we can see exactly what's inside this file. So we were creating now, this is now splitting based on 1 byte, so it's splitting into each character. We created in this step we created 1, 2, 3, 4 files. Those 4 files were then flat mapped. We'll see this tomorrow, but this is essentially making them flat for each object and then make it flat. And then we can print the contents of that. So another way of writing this, if we just wanted to see, okay, what was inside that channel that we've created. So creating a channel, 4 different files. We can see the files themselves by just doing a view on them. And we'll see that there was 4 files here inside this working directory, which got ran. Okay. What's probably even more useful, though, is to dynamically define these output files. And this is something which will typically happen when you have, for example, an output file which will be called after a sample ID. So some software generates output files which you don't necessarily know what the name is beforehand, or the name is dynamically defined. So I'm going to take this process here. The key thing to see is that the output file here is now being defined from the input. So the file which has been created is the Nextflow variable x.align, which is coming from here. And then the file itself is being selected from here. So we can get rid of this for now. Imagine that we had species, which was a channel, which was consisting of human and mouse in this case. Okay, so we have a channel called species. It contains 2 strings, human and mouse. They are inputs to our process. And then we're going to do a process. Each task I want to run the sample itself. In this case, it's just a value, but you can imagine that this was a file. And the key is the output file here is going to be called, in our case, it's going to be called human.align and mouse.align. Now we can capture that using this file and then the variable name here into a downstream process. So let's say genome into a downstream task, right? So genomes.channel view. Okay. This should be genomes. We can see that this is created now, 2 files, mouse, human. Okay. Composite inputs and outputs. We touched on this briefly before, but this is when the structure of the channel that we have, the elements of the channel that we have are not necessarily single files or single types and values, that they're actually tuples. And we see this from the from file pairs ChannelFactory, which produces a tuple, which is the sample ID, a value, and the files themselves. So we can define this with a tuple, sample ID, and the files themselves. And outputs can be exactly the same as that. And this can be very useful for if you want to pass around a sample ID or an identifier, or very commonly something that you want to group on later on. So imagine that you have a sample sheet that you're doing your analysis from, and you need to group things based on, it could be some experimental condition. Now you can pass that experimental condition along with your channel. It can be, you can have as many values as you want here. You could have sample ID, you could have date, you could have even more complicated structures. You can even have the value here doesn't necessarily have to be a string, but it could even be a dictionary which contains a sample and can contain sample information. So we have all of these ways that we can pass along data inside of the processes, which we can then also capture as our output. Notice here that we're going to use the same structure as the input as the output, which means that the sample ID will be passed along to each channel as we go along. So now this BAM channel is a tuple which contains sample ID and the BAM file itself. The BAM file is the one that which we've just created here. Another thing you'll see is that is the tuple and set. So tuple is more common, more recent addition to Nextflow. There's full backwards compatibility across the same. You'll see some with set in there, but tuple is the kind of the main way of going with this. Okay, and final thing for today before we stop for this is to look at the when declaration. So when enables us to determine exactly if a process should run or not. And it's useful in some situations. You have to think of the logic of how this works. So the process, as I said before, is always on. It's waiting to be executed. And then when the inputs are satisfied, so that we, for example, receive a FASTA from the proteins channel here, and if we, for example, have the parameters type here, only then will it look at the condition. So we'll look at this when condition if it's specified. So when, for example, FASTA.name equals these variables, and when the type is that, will we run the script? Let's just check the example of that. It should work pretty well. Let's do an echo on here. Okay, so you can see that if we look at ls on that data proteins again, you can see we have 6 files. And if we run this by default, we can see that we are specifying that inr is the database type, that we have all of these files, and that we're running for each of the FASTA type. We're going to run for each of the files there, we're going to run this, but only when the FASTA name equals this and the type equals nr. So I could run this again, and I could say, remember we can change our parameters with dash dash. I could say that db type was something like, I don't know, DNA. And when I launch this now, you see that the process began, but it didn't satisfy the conditions of when. And when can be useful for some situations, but in some ways it's slightly different from pure data flow programming in that we're not having the channels that are defining the execution of the process, but we're basing it on a kind of more iterative approach. So something to keep in mind is that that will change the whether you want to go with this approach or go with something where you're executing based on the contents of the channels. Okay, I won't go into directives for now because it's a kind of more important part. We'll start with that tomorrow. So tomorrow we'll go through and start with directives, which are kind of config for our processes. You can see these. We've already seen some before, like echo, but these are some examples of CPU, etc. We will look into operators, so how we can then change the contents of our channel, so how we can change those. And then in the second part of tomorrow, we'll go through an RNA-seq example and we'll pull all of this together. So we'll pull together the channels, which we've seen today, the processes, the operators, and develop our own pipeline from scratch from there. So if there's no questions on that, we'll see you all back there tomorrow. Thanks a lot for your interest and for taking part. And if you have any questions as well, keep them for first thing in the morning and we can go over those. If anything you've seen today is not very clear. All right, thanks a lot.